Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic, and today we'll start second pattern, which is expression evaluations. And today we'll see the very first question, which is basic calculator 2. So let's read the problem statement. It says we'll be given a string, as you can see here, plus multiply, divide, minus, all the operators will be given, and you may assume that given expression is always valid and all intermediate results will always lie in a integer range only. Okay, you are not allowed to use any built-in function which evaluates strings as mathematical expression. Means every function you have to build, and at the end you have to evaluate this, and you have to send the output. So as you can see, 3 plus 2 into 2. If you know the BODMAS rule, we multiply and divide first, and then at the end we plus, like add and subtract. So as per that rule, definitely we will multiply this 2 and 2, which will become 4, and plus 3 will become 7. Very simple task. But as you can see, there can be extra space as well that we have to ignore. Okay, that will take care while we'll write the code. Now let's read the constraint. Constraint says S length can go till 3 cross 10 power 5. Okay, why we read? Because if you are following my playlist, you would have understood till now ki why when code goes beyond sometimes 9 into 10 power 8 also, and beyond 10 power 9 it gives us TLE. And if it's above 10 power 8, like in between 10 power 8 to 9, then it will be very slow. But sometimes 10 power 7 code also give us TLE if the logic is so complex. So in this case, as you can see, 10 power 5, so n square will become 3 cross 3 means 9, and 10 power 5 cross 10 power 5 means 10 power 10. Definitely this code give us TLE if we'll do the brute force approach. But first let's see the brute force code, and let's understand the problem how we can do, and then later we will optimize this. So as you can see here, 3 and 2, correct, and the operator in between this. And as you know the rule of BODMAS, we cannot do addition and subtraction earlier, even though we found. Okay. So if you are thinking of for iterating from this index, and once you found the operator, still you have to write the logic such that ki if plus or minus is there, still keep moving, correct? And once you found this multiplication, so for this, if you are at current, like if you are present at this index, you need this number and next number to what? To calculate it. Yes. How can we do that? This to suppose we can store. If you are standing at this multiplication operator, this we would have visited earlier, so we can store it somewhere. But what about this? This also we have to take it, right? Then only we can multiply this. So don't you think in our brute force approach, we can just put all our numbers in a separate array and then operator in separate array? Yes, I can do. And if you will see, this numbers length, like array length is 3 and this is 2, means the operator will always be 1 lesser than the numbers length, correct? Yes. Now what we want, this is plus, so what I said, we will not do that, correct? Now what we'll do, multiply or divide? So now we'll move to this next one. What is this? Multiply. But for this, where is the exact number which needs to be multiplied? What are those two numbers? So if this is indexing, means suppose this is 0 base index and 1, this is also 0, 1, 2. So for this first index, what I want this and this, correct? So can I say ki for this first index, suppose this is nums array and this is ops array, operators array. So what I want, I'll just write the condition ki if my ops of ith index is equal to what? Either multiply or ops of I, that too you can write, correct, is equal to divide. If any of these two cases returns true, means we can evaluate it, correct? So what we'll do here, ki if ops of I is equal to multiply, so we want to multiply, so in result we will store ki result is equal to nums of I, correct, multiplied by nums of I plus 1. Very simple. Yes. Else definitely it is divide, then in the result what we'll do, nums of I divide by nums of I plus 1, correct? Yes, we can do this, but at first we have to iterate, we have to read every element. If this is a digit, we will save in nums array. If this is operator, we will save in ops array, correct? Now next time we will run this like the for loop. For ops length, one by one we will read the operators. If this is multiply, no it is not. If this is multiply, yes. So if it is multiply, the index, same index element we want from nums and I plus 1, we will multiply this, correct? Okay, but what to do with the result? You can either save it in the result, like the result variable, or else the better approach is, because this is 4, correct, the result, but still this result is not the final result if you see, because after this suppose divide operator is there and divide by 2, then to this result which is 4 needs to be divided by 2, correct? So hence this 4 result we cannot take it, correct? So hence what we'll do, instead of saving it, we will rewrite this, what, 2 to the 4, that's it. Means what we do here, 2 was there, 2 was there. So at the same location we'll put 4 and I plus 1th we will remove from the list. Okay, so hence nums and ops list we will make. Now after that it will look like this, correct? And also we have to remove this multiply operator as well, because we have already calculated, correct? So now the size will become 1. Okay, now the very first for loop which we made to actually calculate all the multiply and divide operator things, we are done. Okay, so whatever we calculated the results, what we do after coming out of this if and else case, we have to save in the resultant in the nums array. So we'll do nums dot set at ith index we'll set result, correct? And also from nums we will remove what, I plus 1th index. So either this if case run means multiply, or else if this divide runs, correct? In both the cases we'll read the previous 2 elements, we'll calculate, and in the nums at the same index we'll set it, and the previous one we will remove it, but from the nums array, not in the string, remember it. Okay, now what, all the multiply and divide operator so we have calculated, so whatever is left over is nothing but plus and minus. So the same formula, like the same for loop, we'll write again. Now if this is plus, we'll add, if this is minus, we'll subtract, and at the end we will return the 0th index value, correct? Means again if we'll run 0th index which is plus, so 0th index plus first index from nums, we'll add it 7. So again at nums of I we will rewrite this as 7, and nums of first index we will remove. So at the end nums of nums array will become 7, and that is my result now. So at the end we will return this nums of 0 as our final answer. Yes, so I don't want to invest more time, so I directly written the code here. We will make the 2 list, okay, for nums and ops, and in we'll run the for loop, and if anywhere we found an empty space, then that we will continue, we'll ignore it, and then we'll check if that character is a digit, then we'll keep on making this num. Okay, what is this num formula? This is nothing but a single digit will be definitely considered easily, like from 0 to 9. But what if it's 19, means 1 9? So first one, next time 9. So how we'll make 1 into 10 plus 9? I hope you know this, correct? Else, if it is any operator, then what we'll do? Definitely in our num variable we have the previous number. So that number we will add in the nums array. Operator will add in the operator array, and as the operator found, so next time again new number I want to calculate, so we will reinitialize this nums from the 0 index. Okay, so by writing this much for loop we will create the nums and ops array. Now what we want, we are running all the num only when we are falling inside the else case, means we are finding the operator, correct? But for the end element which is 2, we have not found any operator and we have came out of the for loop, so that is still pending, right? So that's why after coming out of this for loop we have to write, hey, last num please add in the nums array. Now we will run the for loop, and again for the op size one by one we will add, we'll check if the ops index value is multiply or divide, then we will read nums of I and nums of I plus 1 value. If it is multiply, we will multiply. If it is divide, we will divide, correct? Now at the ith index we will set. from the I plus 1 we will remove, and from ops also we have to remove, considering that this ith character, which is the operator, we have calculated, correct? Or else means, suppose if it is not multiply or divide, means for sure it is plus or minus, correct? So in that case we'll keep on moving. Okay, now again we have to run the same for loop, and now this time we will calculate for plus and minus. Because why we are doing this? Why cannot we do in the same? Because we are following the BOD-MAS rule, remember. So multiply and division we will do in another for loop, and addition and subtraction we will do outside, and after the end, like at the end, we can return the result. But what is the time complexity in this, if you'll say? First, so for loop we have created to fill our what? Arrays, yes, so O of n. Then again another for loop we are doing, correct? So O of n, and again O of n. So you will say 3n means linear. No. If you know from like what is nums list, so whenever we are removing any index value, so unfortunately now we are actually arranging every index, every value out after that. Means suppose we have number 2, 3, 4, 5, 6 and 7, correct? And now I said like these are the indexes for it, and now I said let's remove 3. So you are thinking it will take only O of 1 time complexity, but no, actually when you will remove this now, so whatever after that will rearrange, like will push themselves towards left side, and now they will be arranged with the new indexes. As you can see, earlier 4th index was 2 but now it's 1. Similarly 5th index was 3 but now it's 2, and so on. So this also takes internally O of n. So hence O of n for this for loop, and inside this, and because of this dot remove operation, it is taking further O of n, which makes it O of n square. Okay, and as the complexity, like the constraint was 10 power 5, so this will be O of n square, and definitely when you submit this, this will give you TLE because it is more than 10 power 9. But no, it passed. But what's the reason? If the time complexity was O of n square, if you see this clearly now, O of n definitely we are taking here, correct? But this we were considering O of n square because of this list dot remove, correct? But when are we actually removing? Like when are we using this remove? Is it for every n, or is it for only those characters wherever we are encountering multiply or divide? So in this case, in the lead code 1, the tests are not generated like this ki the number of operators like multiply and divide are so much. Means suppose if the operators were like 1, 2, divide by 3, multiplied by 4, then multiplied by 6, then divide by 10 and so on, then definitely for n numbers there are nearly n by 2 operators, and for every operators we are actually what? Removing. But here as you can see, 411 is not considered of one size, it is of 3 size, correct? Because this is in string format, right? So 411 are of 3 size. Again 1000, it can also be there, 10,000, 1 lakh, and out of all such string, means every character, there will be very less all those operators which are multiply or divide. Like there can be plus also, minus also. For that though I am not removing, correct? So hence in this case the multiply and divide operator used in the test cases are less, and that is the reason it has passed and it shows it's fast, but it does not mean it's optimal, correct? So in this, the very first for loop is actually taking O of n. Similarly inside this O of n, but multiplied by how many number of times multiply or divide operators are there. Let's say k. So O of m into k, and here in this case O of n again. So it is not optimal. How can we optimize this such that these many O of n will reduce? So let's try to optimize this. Okay, so in this one definitely we are going back, means whenever we are encountering any plus, correct, or minus, we are not calculating anything then and there. Yes, and whenever we are encountering the multiply or divide, then we want to calculate. So can I say nothing is there means plus? Why I did this? Let me show you. What I'm saying, whenever plus, like whenever 3 is there, minus 3 is there, anything that we want to save it. So let's take stack. Okay, let's take stack. So what we'll do, we want 2 variables. Like very first variable will be wherever we are running this I. Okay, yes, and second variable I want is operator. I'll tell you the reason, and that operator will initialize with plus. Okay, now ith index is indicating a digit, correct? So that means if we'll run the for loop, first of all, we'll run the for loop for int I is equal to 0, I till less than what? S dot length, okay, and I plus plus. And if this S of I dot is what? Digit, okay. If it is a digit na, then what we'll do in a num variable, like how we calculate, we'll add the number, suppose 3, we added. Now else if this S of I what is not is equal to the empty space, okay. Why I said this? Definitely the else condition will run only when S of I is not a digit, correct? And now it can be either operator or empty space. So I am just checking ki if it is not empty space, then definitely it is operator, correct? So now what we'll do, S of I is nothing but suppose ch, okay. So S of I, let's say in ch we'll save S of I, okay. So what I'll do, ch. So if now I'll read the previous operator y. See, currently I am at operator which is plus, okay. So now what I am saying, I'll read this. Why? Because you can just see when I can add this, tell me. Only when 3 plus 2 both are encountered and saved, 3 and 2 both are encountered and saved, correct? So it means I am here on this multiply, then I am deciding what to do with 3 plus 2, correct? So how we can do, like what operator we have to do with 3 plus 2, how we will recognize? By saving this operator also. So that's what I am saying. Few things we have to carry is the previous two numbers we will store in the stack, okay. Currently I am at any operator, and whenever I am finding any operator, then we decide, okay, we have to go back and we have to what? Operate in these two. But what operator we will use? That we have saved in the previous operator variable. That's what OP was, correct? So the idea is very simple. It might feel little clumsy, but trust me, it's not. The only thing is ki we can only operate these two numbers. Like just remember this rule ki we can only operate these two numbers when we have these both numbers cached in the stack, okay, and the operator saved in some variable, correct? Why it is saved in variable? Because we can only operate these two numbers from the stack when we have already encountered this and we are on a next operator, okay. So now we are at this operator. So what we'll do, we'll check what is the previous OP. Previous OP is plus. That's what I said ki any number which has previous OP plus or minus, for those we will not do anything, because following the BODMAS rule we will only do multiply and divide, and for any plus and minus things we will just saved in the stack, okay. So we will write ki if OP is equal to what? Plus, then what we'll do, we will in stack we will push. What will push? That number num which we have saved in the variable, okay. Now else if, suppose else if OP is equal to minus, then what we do? Obviously we'll push in the stack. In the stack we'll push, but minus num will push, okay. So as of now definitely plus 3 means simply 3 will be pushed, correct. Now next time definitely OP will become plus, this will be the number and this will be my I for multiply, correct. Again when we reach the next operator which is multiply, we'll go here and we'll check ki if it is plus, like if the previous operator is plus, previous operator is definitely plus. So what we'll do, in the stack we'll push to again. Now what we'll do, as you know we are doing like we are solving the previous two only when we are encountering any operator, correct. So at the end now we have to add a plus sign, okay. Why we are doing this? Because this number we will get from stack, this we have saved in the operator variable, this we have stored in the num, like current num variable, and this we are present at it. So again we'll say ki yes, this I is operator, S of I is operator. Then we'll go here and we'll check, is the previous operator is plus? No. Is the previous operator is minus? No. That's what we'll write the next case. Else if what? If operator is equal to multiply, then what we'll do? As you can see, this is multiply, this is in num, and this is present where? In stack. So now what we'll do? Stack dot pop multiplied by this current num, correct? So we'll pop from the stack 2 into current num multiply, and again this 4 will push in the stack. 4, yes, correct. So now what we'll do, let me erase this for you. So if it is multiply, in the stack we will push, but what will push? First we'll pop from the stack, which is 2, then we will multiply this number that we will push in the stack. Else what? This means OP is nothing but divide, can I say? So in that case also again we'll do stack dot push, but what will push? First we'll pop that number, we will divide with this number, and then we'll push. Can I say this? Yes. So at the end in the stack we have this, and we will come out of, like I will come out of this loop and we'll say this is what we have in the stack, 4 and 3. And now we can run this, and now we can run this. We'll pop this 4, we'll pop this 3, and in a resultant variable we'll just add it or subtract it. If it is negative, so definitely it will be with negative sign. So 3 plus minus 4, which is minus 1, but in this case it's positive, so 4 plus 3 will become 7. As you can see, just by running one single for loop and using the extra space for this stack, we have completed this in just O of n time complexity. Yes, which is far better approach than the previous one, correct? If you talk about space complexity, definitely we took O of n space complexity as well here, but in previous approach also we were making 2 different lists, correct? That was also taking space, right? So hence this approach is far better approach. The only idea is very simple, the steps we followed. Ki for any operator, like to evaluate any such expression, we need 2 numbers and the operator. So first number we will find from stack. The operator we will save in the OP. The current element, like the element, the second operand we would have saved in a num variable, and we will only evaluate this expression when we find any another operator, correct? Okay. Now once we calculated this, now I forgot to mention here, this current S of I needs to be updated, like means this OP, previously OP was plus, now to the OP needs to be multiply, na, so that next time when we'll be present at this plus, this like previous OP will be multiply. So basically we will update our OP with the current element once we are done with this approach, like this method, like operators, whatever operations we are going to do. Okay, so I hope you understood a little bit. Okay, so let's write the code from scratch. So first we will write stack of type integer. We'll make a stack for us, new stack. Now we want a variable called int num, where we'll save the numbers, and also we want a character OP, correct, where we'll initialize this with plus. Now we want to run our for loop for int I is equal to 0 and I less than equal to s dot length, correct, s dot length. Okay, why equal to? Because if you remember in our code, like in our whole character, at the end we added a plus extra, correct? So for that we want our index to go and run till that index, so that's why it's equal to and I plus plus. Now what we want to read the character, correct? So it will be of type char ch is equal to, definitely it will be s dot char at ith index, yes, but if you remember the last index, so if we touch the index I, which is equal to s dot length, correct, gth length, yes. So if we touch that, so definitely we want our character to be plus, yes, or else this caret I. Okay, I hope you understood this. Now we have to check ki if character dot is digit, okay, character dot is digit. If our current character is a digit, then definitely we have to update in our num by num multiplied by 10, correct, plus this ch minus 0. Why we did this? Because it's in string, so we have to read the sky value and then we have to make the num. Now else if we have to check if character is not equal to the empty space, then definitely it's a operator plus minus multiply divide, correct? So now we have to say ki if our previous operator is equal to the plus sign, correct, then in our stack we have to push the number as it is. Can I say this? Yes. Now we want to write else if, correct? So else if the operator is minus, then in the stack we want to push minus num, correct? Again we want to write else if and else if. So if the operator is multiply, then in stack we want to push stack dot pop that element we want to multiply with that num, and that then we want to push, correct? Again stack dot push, first stack dot pop will get the element and then we will divide with the num and that will push. Now what we want, this operator, we are done with this current expression. Now we want to update our OP. So that OP we want to update with the new, like the current ch, and the num also we want to reinitialize with 0. Why? Because from next time we want to read this num, correct? Now after coming outside the for loop, we are done with this. In the end we will have all the characters with plus or minus sign in the stack, and now that we will add either with plus or minus sign, simply we'll add that, and that the final result will be our final answer. So int answer is equal to 0, and we will run the while loop until our stack dot is empty, means until our stack is not empty. Simply we'll add in answer stack dot pop one by one, and we'll end up adding all the numbers, and at the end we can simply return our answer, correct? Now let's run the code. Okay, I think we are somewhere wrong. Okay, this OP, okay, this will be a divide operator. I think that we were missing. Yeah, now done. Now we can submit this code, okay, and this will be optimized one. Yes, so this is your Java code. I hope you understood the logic with brute force and optimize and why we are using stack. And if you are done, so this is Java, and the similar logic we have written in the Python as well. If in case you guys are from Python, then definitely this code will be helpful. And here is your C++ code, and with the similar logic, like we have not changed anything, okay, just to show you fast. And if you are done, if you understood, then we can go in the sheet and we can mark the very first question of the pattern as done. Yes, and please do let me know in the comment section, guys, if you understood the logic, the concept of brute force and optimized. And I hope you understood the reason of that previous, which looks like O of n square, but it was not, because of the test case also, like how lead code generates, correct? But time complexity wise, the stack one is the most optimized one, and that's what the interviewer expect you to answer, correct? So if you understood, please do let me know in the comment section ki you have solved on your own, and you have not just copy pasted my solution, correct? With the proper dry run you can do, and just let me know in the comment section. And please do like the video and subscribe the channel if not yet subscribed. And that's it for this video. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family.